The launch of our low-power cab drive piezo haptic driver architecture revived the industry's interest toward piezo-based tactile effects. Since piezo technologies are different than ERMs and LRAs, we need to share a few mechanical fundamentals to optimize their integration. We'll learn why replacing an ERM or an LRA isn't simply a matter of bonding a piezo actuator to the device with adhesive. To successfully integrate piezo haptics, we first need to understand one of the most fundamental laws of classical mechanics, Isaac Newton's laws of motion.
First law. In an inertial frame of reference, an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. Second law. In an inertial frame of reference, the vector sum of the forces F on an object is equal to the mass m of that object multiplied by the acceleration a of the object. F equal ma. It is assumed here that the mass m is constant. Third law. When one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction of the first body. Comparison charts use acceleration to compare each actuator's feedback strength. Feedback strength is in reality the force of motion of the actuator. Since they are all compared with the same mass, you can isolate the acceleration from Newton's law. Therefore, it is true that the actuator with the highest acceleration value will create the strongest feedback, but their performance isn't measured exactly the same way. Acceleration benchmarks are a bit tricky. While it might be true that bonding an ERM or an LRA to a given mass will be enough to move it, you can expect the same result by bonding a piezo actuator. The piezo actuator's acceleration value is measured with the mass on top of the actuator. We'll see why it's different and why you need to use a different approach to successfully integrate piezo haptics in your product design. We've seen that haptics are defined by Newton's law of motion. To create a force, haptic actuators need two components, a mass and an engine to generate an acceleration to it. When comparing haptic technologies, you are ultimately comparing the type of engine they are using to generate acceleration. Let's see the components behind every haptic actuator, and we'll see why you can't directly replace an ERM or an LRA with a piezo actuator. ERM's vibrations are created by rotating an eccentric mass with a DC motor. The mass movement creates an unbalanced force, therefore vibration. Newton's motion law principles are respected. The eccentric mass and the engine's rotations create a moving force that transfers from the actuator to the device to which is bonded. LRA's vibrations are created by the suspended magnetic mass driven by a voice coil. Driving current to the voice coil creates a magnetic field that can move the magnetic mass on the same axis that the springs are aligned. The magnetic mass needs to oscillate near its natural frequency in order to resonate and create the biggest force. Here again, Newton's motion law principles are respected. The suspended magnetic mass m, movement thanks to the voice coil A, creates a moving force that is transferred to the device via the springs. For this example, we'll use TDK Power App piezo actuator lineup. These piezo actuators don't work like piezo benders. Instead, Power App actuators mechanically contract when they're under tension. The piezo material contraction forces the metal cymbals to expand. This is how the actuator can push against a mass. If you are trying to push a mass on one side of the actuator, the other side needs to lean against a surface that will transmit the force to the device, which has a mass. Again, if your device is submitted to a force and has a mass, Newton's second law dictates that your device will end up vibrating. The reason why piezo actuators can replace legacy technologies directly is because they are not haptic actuators. They are engines. Just like ERM's DC motor and LRA's voice coil, piezo actuators don't have built-in mass. If we look at Newton's motion law principles, the piezo actuator is the engine and generates acceleration, but we're missing the mass to create an impactful motion force. Does that mean it's impossible to replace LRAs and ERMs with piezo haptics to vibrate a complete device? No. It means you need to find a mass to move with the piezo actuator to do so, and we believe it's an advantage of the technology. It gives more flexibility to tune piezo haptics to get optimal tactile effects depending on your goal. Combining a piezo actuator to a small mass is perfect for localized feedback and to replace mechanical buttons. Combined with heavier mass, piezo actuators can create enough force to vibrate the whole device to which is bonded. The device can also be the mass itself, like an automobile display. You don't have that level of flexibility from legacy haptic technologies.
Now you understand why you can't directly replace an ERM or an LRA with a piezo actuator. Piezo haptics require a different approach, but offer more flexibility. We hope you enjoyed this video. If you need some help to integrate your piezo haptics, don't hesitate to contact us at sales@boreas.ca. We have a mechanical engineering department ready to help you. Our team can help you achieve better results and facilitate the integration of piezo haptics. Thanks, and I'll see you in the next video.